Hello friends, I have a new item for repair, but it's not new. It's a large item. This is an Extreme Networks Summit x450-G2-24P-GE4. It is a enterprise grade switch. In fact, it's not just an enterprise grade switch, it's a top of the line switch. This is a switch that cost thousands and thousands of dollars when new. It was removed from service and replaced because it has a fault, because it fails to power any Power over Ethernet device. Power over Ethernet, or PoE, is a really cool feature of networking where you can get power from the one cable that connects you to the network, the RJ45, Cat5, Cat6 cable, whatever. And so this is a 24 port switch. And if anybody doesn't know what a switch is, it's basically a splitter, a network splitter, but it has all kinds of features in it. I'll demonstrate the fault to you in a minute when we plug it in and turn it on, but basically it does seem to have network connectivity with devices that don't need PoE, but when a device requires PoE, it's not turning on the port, and there's no link. So okay, so here's a mess. Alright, so we have my laptop plugged in, and then we have an IP phone, which is PoE, plugged in. So it should be... By the way, when these switches come out of the box, they are configured with all the ports turned on with PoE. By the way, if you've ever walked into a server room and you hear a lot of background noise, it's the switches. Some indicators there. Still finishing its boot up process. It's going to take a couple minutes. And significantly, we have here two LEDs on the power supply. I had to use magnification because there's something stamped in there and indicates what they are. One of them is for input and the other one is for output. On our laptop, we have a link light for where our laptop is plugged in. Okay? And where our IP phone, our Power over Ethernet device, is plugged in, we've got nothing. So, yeah. So that's the confirmation of the symptom. The environment that these switches were put into, they were unconfigured. They were not set up. They were in the default state, that's what I was told, and they, by default, should have Power over Ethernet, so there's no reason why this wouldn't work. Now you're thinking, okay, well, where's the reset button, right? The way to initialize these switches is to log in with the console and execute the initialize command, the default command. So I guess that's probably what I'm going to start with. Okay, so the cable that came with it. So the console port's labeled console down here. It's an RJ45, and this is an RJ45 to DB9 cable. It's very typical for Cisco equipment and apparently Extreme Networks as well. It's probably the same pinout too. And then we have a USB to serial adapter, and these usually work pretty good. And then we're just going to open up a terminal program on our laptop. So I actually use HyperTerminal. I have to get into older equipment all the time, and I actually use HyperTerminal. Okay, so it looks like it might be 9600. There we go. So admin is the username and password is nothing, and indeed the management console is working, and I have the procedure for resetting it. Unconfigure switch all, restore all. Okay, that's good. Alright, so it's gonna, all stacking have been reset. Yeah, automatic priority. Yeah, okay. And this is another thing you can do when you're diagnosing network equipment with a CLI, is you can hook your serial port up to the device and reboot it, and you should have some some data that comes up, some, you know, the booting up sequence should come up, and also possibly give you an option. Like I could have held the space bar to enter the boot ROM, but I don't need to do that. I'm just defaulting the switch. I don't think there's anything wrong with the configuration of the switch. I was told it wasn't configured. It didn't have a password in it. That kind of tells me it wasn't, and it had all those prompts that it was asking me, which would seem like you would only be asked that during a default console entry. But looks like it might be, yeah. So anyway, there's a couple of after I get by all these questions again, I'm sure. Yep. Just do all that. There's some commands that I can put in to check the status of the ports for PoE. Let me look that up real quick. And that command is show inline dash power stats. Okay. Would that be, there could be something wrong with the hardware, and that you can't, yeah, so that's probably what it is, and that's probably what I suspected it was. I mean, what's the most likely thing to go wrong when the PoE is not available? Suddenly, spontaneously, nothing else came into play. It wasn't dropped or flooded with water or whatever. Somebody didn't plug a battery into it or whatever. It's probably power supply related. So that's why I'm hoping like maybe I can fix this, because this thing is worth a lot of money, even though it's end of life. They don't make them new anymore, but they're still worth a pretty penny. So it would be a shame to have to e-waste it. We can put it back into service somewhere else if we can get it to work again. Let me pause the video here and come up with a game plan. Alright, so here it is inside an Extreme Networks enterprise switch. A little bit dusty. Looks like there's not going to be too much trouble testing. The power supply. Look at all those pins in the power supply. I don't know if you can see that, but it's kind of dark. But there's, yeah, lots of pins. So I think we might be dealing with more than just your requisite 2 voltages, you know, one for the PoE and another one to run the other components. So in visual inspection, I guess, only thing is this thing, what do? Take the can off of it and then stick it back in, maybe? I can't get to all the pins from here. I guess I'll get my magnifier and possibly look for some test points or something. Actually, this with these wires and the thick connections and stuff, technically PoE is 48 volts. Yeah, let me grab some magnifiers and check some stuff out here. I should try to plug in directly between these. Yeah, okay, there we go. 56 volts. See, that's what you would expect. 56 volts. 56 volts, okay. So 56 volts coming into this board. We're probably talking about a failed component. Ooh. And I think I might have found it. Visual inspection. So on this board, which literally connects to the Ethernet ports and has a bunch of diodes and says 24-port AF/AT-PSE module, and then right above it it says EVT24PoE, and we have 50 volts, 56 volts coming into it. We have this, and this is, I believe, a burn mark on this chip. Question is did something else blow that chip, or did that chip just blow itself spontaneously? That would be the question. So I think, I mean, I'm not much of an electronics engineer, but I might be able to trace that down. Get the data sheet for this chip. I think we can see it. The number. Yeah, LM5574. So that's going to be some sort of voltage regulator, I would imagine. Yeah, it's a regulator. It's a step-down switching regulator. Ultra-wide voltage input from 6 volt to 75. Integrated 75 volt MOSFET. There may be a culprit right on the center of your screen, right there. See that little shiny ball? That was sitting right on top of that chip where it burned. It's possible that somehow that chip pushed out a piece of what, no, that's a solder ball. I mean, it looks kind of brassy, but then that's probably because, well, I mean, that's not normally what solder looks like, because, you know, when it gets hot, it doesn't change to a brassy color or whatever. But I mean, if that solder ball shorted, let's see, it would either have shorted with pin 2 or pin 4. I mean, that thing was tiny. But hey, man, you're putting you know, 56 volts into it. That's, yeah. And pin 4 is the sink, and that kind of looks like where it looks like the pin 4 side of it. So maybe 56 volts went into pin 4 or pin 2. Yeah, and that would have done it. That stupid little solder ball. That thing was pretty microscopic. Wow. All right, well, that points me in a pretty good direction. That gives, so I'm going to order another one and replace it, and we're going to find out what happens. I and others have videos covering TSOP chip removal and replacement, so I won't cover it here. To make a long story short, I wound up using ChipQuick SMD1 lead treatment to remove the chip. The kit simply includes solder that, when added to the joints on the board, greatly reduces the melting point, making it super easy to remove the component. There is an Amazon link in the description of this video if you want to check it out. Anyway, finally got it in. I went ahead and tested continuity to make sure I wasn't shorted between the pins, and a couple of pins were shorted that shouldn't have been. Well, there were several pins that were shorted that shouldn't have been. And but one of them it goes over to a diode that was right next to it, and that diode was completely internally shorted. I downloaded schematics data sheet for this chip, and it showed how to use it in a circuit and what to put, what passive components you need around it and stuff. And yeah, there was a diode supposed to be there. Measured the diode in both directions. Completely shorted, not even a voltage drop. And I thought, oh no, I got my 2 pins shorted because it's 2 pins of this that go to the diode. As far as I could tell, I didn't make a mistake there, so I decided to take the diode off, and sure enough, the diode itself was shorted. It wasn't me. So anyway, so I got that done, and we're going to test it out. Okay, moment of truth. Hopefully we don't have any magic smoke. And we have our IP phone plugged in. It's not going to work right away. We got to give it a minute to boot up. What do you know? Got a link light. And the IP phone's coming up. All right, all right. Thought the job was done. But I thought wrong. The IP phone stopped working and then it came back on, and then I decided to feel the chip that I installed with my finger, and it's red hot. So I'm going to go and test the passives. There's not that many of them, and see if I can. The alternative, I can also remove this chip again, and then I can test the pads and see if I have any goofy voltage on them that shouldn't be there. There's not a whole lot of things that will make a chip like that heat up. Having replaced that chip, I've discovered that, you know, maybe it wasn't a solder ball, maybe something else, and that would sort of better explain how the diode was also faulty. I'm going to take that board back out and check passives, resistors and capacitors and stuff, and see if I can find a shorted or an open device. Okay, so this thing really threw me. Basically what happened is I put the replacement chip in here and it started to heat up big time. And so that basically told me that it wasn't a solder ball. Whatever I found on there, who knows, it was right next to where the chip burned. Maybe the chip spit it out, whatever that was. Maybe it was a piece of metal from the inside of the chip or whatever. So I put the new chip in and it got hot, like very hot. And I'm like, oh geez, okay, so I've been going the wrong way. So I decided to remove the chip one more time, and you know, and then maybe test for shorts. I began looking at this diode because this diode was just on the other side of this inductor from the 5-volt output. The 5-volt output actually comes this way. And then I guess it's fed back in with this inductor into the chip for 5 volts to provide, you know, all this stuff, whatever it is. And then there's a diode that separates it, and of course the one side of the diode is connected to ground, this way. And I actually found that this diode, it's a Schottky diode, it was actually open. So I didn't have any SMDs, but I did have a Schottky diode, so I put that one in there. And I got the genius idea of, with the chip removed, I could power this board because I know where the 5 volts needs to be. And so these first 3 pins are the negative signal for the PoE, and these other 3 are the 56 plus volts plus. And the reason why it's 56 instead of 48 is PoE, is because they use diodes here, and when you use a diode it drops the voltage a little bit. These 6 chips all need 5 volts of power, and guess where they come from? They come from this little circuit here. So I went ahead and found a good place to solder a lead, and then used my bench power supply, current limited, to about 1.5 amps, and I applied power to it, and it was sucking all the amps. It was sucking all the way up to 1.5 amps. And when I looked at the spec sheet for this step-down regulator, it's 0.5. So that's why it was heating up, because it was getting too much of a draw from something. So with that part removed, obviously it only leaves passive components. I mean, I guess one of these chips, controller chips, could be partially shorted or something like that, or just otherwise pulling too much power. And I noticed that this whole corner of the board is getting warm, this whole area right here. And I narrowed it down to this inductor and this diode, which were both, this was an SMD diode. You could see I replaced it. But there was an SMD diode there, here and here, and I didn't have SMD diodes. This one's a Schottky, and this one is a Zener. And well, long story short, it turns out, even though this Zener diode tested good, in circuit, and then when I lifted one side off, it was passing electrons one direction but not the other, but it didn't, so it seemed like it was good. But when it was in circuit, there was a 1.5 amp draw, and then when I took it out of circuit, the 1.5 amp went down to like 0.1 amps. So, you know, that's not a failure mode that I've ever seen a diode make. You know, when I test it using a diode tester in my multimeter, you know, the multimeter puts like 1 volt or through or whatever, and in one direction it'll pass electrons through, and in the other it won't pass anything, and you get like a 0. Well, but if my multimeter passed 5 volts through, I would have seen that it was passing electrons the wrong way. So that was pretty frustrating. I mean, I guess it's a good learning experience or whatever, but I mean, I spun my wheels. I spent a few hours on this before realizing that I had a bad Zener diode. So it's kind of easy to trace because everything for this circuit is on this side of the board. This is a multi-layer board. The 56 volts of DC has its own layer in there. There's also obviously a ground layer, but there's also ground planes on this side. So there's a bunch of ground planes on this side, plus I believe there's probably a ground layer for EMI or whatever. But there's a 56 volt layer, and there's also the 5 volt layer, because I don't see any traces coming from here on either side of the board, coming from here over to here. The 5 volts powers these optocouplers and probably this chip here, which I don't even know what it is, and these controller chips. So they just get power through a via. There's a via right next to the power pin, and it just goes into the board. So that tells me that there's a 5 volt plane on this board, an easy way to distribute 5 volts, because basically you need it from one end of the board to the other. So anyway, so now we have a Zener, replacement Zener diode. This is the Zener diode. I looked at the number. It's supposed to be a 3 watt Zener diode. It's a 915B. 915B is a surface mount 3 watt Zener diode. And this one here, this Schottky diode, is a SS210. So that matches pretty much. They actually tell you exactly which diode it is here, unlike some of the other components. But yeah, this sheet does not include this Zener diode in this diagram. It was added, you know, for some reason. So anyway, I'm going to go ahead and solder that chip back on here, and we're going to remove this test jumper, and we're going to test it again. Okay, moment of truth. Second moment of truth. Chip's getting a little hot. Ooh, it's getting very hot. Yeah. Moment of truth, moment of fail. You know what? Yeah, that chip is hot, but it's only 120, 115 degrees Fahrenheit. I'll put up on the screen how much that is in Celsius. This chip is rated to go up to 150 Celsius, and this is nowhere near 150. This is more like 50. And you know what? The phone's working, and it's not shutting down. I think I fixed it. So that chip is supposed to be dead hot. So yeah, I believe that what happened is we had a diode that failed on the output. But yeah, I think we have fixed this switch. I think we just need to do a little more stress testing. probably do that at work where I got multiple IP devices I can plug into it. But yeah, I'm just going to clean this up, put it back together, and do some more testing and put it back into service. Anyway, friends, thanks for watching. Another successful repair. Yay! Talk to you later. Bye.